Gross combined mass, or GCM upgrades for passenger and light and medium goods vehicles is not particularly new in Australia. However, in recent years, the Queensland and Western Australian governments, in conjunction with the aftermarket industry and the AAAA, have produced the test standards to provide the procedures and the guidelines for how you do verify a GCM of a given vehicle. This is commonly used by companies to develop a GCM upgrade as part of their build kits, which usually goes in conjunction with their GVMs or SSM improvements as well. I'm not going to go into great detail about what GVM and GCM and BTC is, but what I will point out, something to remember that's very important, is that a GCM is not just the GVM plus the tow capacity or the BTC added together, because weight from the trailer does get added to the car, so you can't physically get a car at GVM and put the trailer at its maximum capacity on the back. So if you ever see a GCM that's got GVM and BTC, the two numbers added together, it's a bit of a red flag. So there is no such thing as a pre-reg or SSM GCM upgrade. This is because the ADRs don't actually list GCM in any of the ADRs. There's no mechanism to approve it or verify it. So as a result, the Federal Department of Transport don't let you list it on your vehicle type approval. And all of these upgrades or modifications are done post-reg or in service, and they have to be verified by the state regulator or their approved person. This means that the OEMs, when they nominate their GCM figure, are working to their own internal standards or whatever they choose and not an ADR. We do find an issue where we've got a lot of popular current vehicles who also cannot meet the test procedure we're going to talk about today in their OEM GCM condition. So this is absolutely no pushover test program. The Queensland LS16 code and the Western Australia VTB 181 code are very similar, except for the fact that the Western Australia code does not permit brake tow capacity upgrades purely because it's banned in the legislation prior to the introduction of this standard. The four key areas that require testing and verification as part of these codes are the same, however, and they are tow vehicle structural performance, which verifies the strength of the vehicle by applying towing loads through the tow bar and the vehicle structure. There's tow vehicle propulsion performance, which is basically checking it has enough power, torque, cooling capability to tow at the given GCM. There is combined handling performance, which assesses the safety of the whole combined mass under different handling conditions. And there is braking performance, which verifies the ability of the brakes to be safe and suitable for that combined mass at its GCM. Each of these test areas are covered by their own unique SAE-J test standard. They all get derived down through SAE-J 2807, which has been referenced by the state regulation in Australia. So to understand what's in a GCM test protocol, you start at the Queensland or WA requirement, you go through SAE-J 2807, and then you go out to multiple other test procedures and standards from there. There's a lot in it, which is why we're here today, and we're going to go out and take a closer look at each of those tests to help you understand what's involved and how to do it properly.
The structural performance component of J684 is a whole vehicle test, which subjects it to various vertical, longitudinal and transverse loads, both separately and combined. The test ensures that the towing loads go through the tow ball, through the vehicle structure and down to the contact patch without incurring any damage. It's a very similar test to our ADR 6202, which we use here for tow bars, but with the key difference being the combined loading that J684 requires.
It's vital this testing is done in a safe location. There's a huge amount of mass and we're doing handling and performance tests here. You can't do this on a public road. So we've come out here to the old Holden, now VinFast Proving Grounds, to do this testing at Lang Lang. Today we're going to be talking about standard vehicle types that kind of affect us in Australia. So talking about the 3.5 to 4.5 tonne tow capacity single rear wheels. So a lot of the criteria we talk about is going to be relevant to those. Importantly, today's not a test day. You cannot test in this weather because it's just started raining and it's way too windy. We're going to be pointing out some of those requirements today while we're out here, but these are not relevant tests, we're just showing you what they look like. The trailer is also super important. This is a dedicated AIC GCM trailer. It has to have the right number of axles, the right length from the axles to the ball, the right ball load, and it also needs to have the right tyre sizes. So let's go out and have a look at some of the tests before we get too wet. Level road acceleration. So for this test, the vehicle combination, again, unsurprisingly, needs to be at or above GCM. What's important is your trailer needs to have this frontal area of 5.57 square meters or more. The track conditions, so you need to have, it's got to be above 10 degrees Celsius. Your wind can't be more than 15 kilometers an hour average and no more than a 20 kilometer an hour peak and no more than 0.5% grade in this direction. So you need a very long, straight, flat road, which is what we have here at Lang Lang, one of the very few places we can do this. So this is a 0 to 60 mile an hour test, which is 96.6 kilometers an hour. There are 3 gateways that you need to meet. There's a 0 to 30 mile an hour gateway in 12 seconds. You need to meet between 40 and 60 miles an hour, that section, in 18 seconds. And you need to do the overall 0 to 60 mile an hour or 96.6 kilometers an hour in 30 seconds for this combination of a single rear wheel vehicle. One test is a run up and back. It's a pair of tests and they both need to pass. And then you need to repeat that 3 times. So what you end up doing is 6 runs, 3 that way and 3 that way, and they all need to pass all 3 of those gateways of 12, 18 and 30 seconds. We found this test actually one of the harder ones to pass. It is an American-derived test, so which is fine for these bigger trucks that come out of America. But some of our lower capacity turbo diesels in Australia do struggle, not just in the upgraded condition, but even in the OEM condition, they struggle to meet it on these lower powered vehicles at that OEM GCM. Launch on grade. So this is where the vehicle combination at GCM has to pull away on a 12% gradient and travel 5 meters up the hill and then do that 5 times within 5 minutes. So it's a case of pull away from a standstill, roll back and do that 5 times facing up, and then you have to do that within 5 minutes without any failures obviously or any warnings, and then you spin around and you do that in reverse. You have to do it on the tallest diameter tyre. That's part of propulsion performance testing. The highway gradability test is designed to punish the vehicle's powertrain's thermal capacity. It's a physical test that's designed to be run in Bullhead City, Arizona, and it travels 18.3 kilometers and climbs an elevation of 924 meters. The test is done in Arizona at a minimum temperature of 100 degrees Fahrenheit or 37.8 degrees Celsius. But in Australia, it's a bit of a hike to get cars over there every time we want to test one. So the test is abridged in some way when it's conducted in Australia. And here at the AIC, we want to make sure that we test the physical vehicle driving on a road. So we come here on this amazing ring road at Lang Lang. We tow the vehicle at the design speed. We have our test trailer with the frontal area that it must have, which is 5.57 square meters. And we hitch the trailer dyne on the back. The trailer dyne does 2 things. It applies the gradient to replicate the gradient that you see on the test in Arizona, but it also applies additional load depending on the ambient temperature to take into account the fact that it never gets to 37.8 degrees Celsius in Victoria. To pass this test, you've got to maintain a minimum speed of 64.4 kilometers an hour throughout the duration of the test, and you've got to receive no D-rates or diagnostics codes or warning to the driver, and no loss of fluid or diagnostic codes, so or component failures. So it is an interesting test. It really does test out the vehicle's thermal capacity, and not every vehicle can pass it. Tow vehicle understeer. As with the other tests, the combination needs to be a GCM, but the difference is that with the trailer, it's a lot more of a precise setup for the handling tests. We need to have the trailer at the towing capacity of the vehicle, and the ball weight needs to be 10% plus or minus 0.5%. Importantly, the trailer also needs to be level within 1% forward and back once it's loaded up and fitted to the vehicle. You also need to make sure that the trailer dynamically meets the requirements of the standard, which is that maximum effective tongue length, and the number of axles and tyre sizes, etc. In terms of the track conditions, the average wind speed can't exceed 25 kilometers an hour. The gradient needs to be within 2% or no more than 2% across the gradient, and you need that smooth, dry asphalt surface. In terms of layout, you need to have a minimum of 30 meters of radius, so you're talking a 60 meter or bigger circle to be able to run this test. So it's a very limited options on where you can fit something of this size to get around there. And what's important is when you're producing the test and you're running around, you do it at different speeds from fairly low, like 20 kilometers an hour, right up to maybe 40 or 50, depending on the vehicle and the combination. And you need to gather steady state data. So you need to get some good runs in there where the data is steady state and you've got constant steering, constant speed, constant yaw, and importantly, the radius that you're traveling can't deviate by more than 0.5 meter from the center through that period. So that's a fairly sort of skilled bit of driving that needs to be done, especially with a vehicle of that sort of mass. And then what you get at the end is you're making sure that the combination, as you increase speed and get closer to the limit handling, it's still a safe response, generally leaning more towards understeer than oversteer. Trailer sway response, the second of the handling tests. As with the understeer, we need the vehicle and the trailer loaded to its GCM, and the trailer has to be very precise in terms of 10% plus or minus 0.5% ball load. We need to have level within 1%, no aero, and again, the right number of axles, tyre size, and maximum effective tongue length. The test track, again, 25 kilometers an hour average maximum wind speed, so average wind speed, which is probably not the best day for it, so lucky we're not testing today. The gradient of the track has to be 1.5% in the direction you're traveling and 2% going sideways as maximum limits. Again, smooth, dry asphalt. The test is run at 100 kilometers an hour, so you do need a fair bit of space, which is why this is absolutely perfect for us. We need to have a steering robot, and what happens is you drive at 100 kilometers an hour, and the steering robot induces a half sine input, so effectively that's a steer in one direction and back to 0 in half a second. How far it steers really depends on what the trailer's doing. You need to get to 5 degrees of articulation maximum, stay within the linear range for this test to be relevant. To measure articulation, there's probably a couple of ways to do it. We do it with 2 IMUs, so we have an inertial measurement unit in the car and we have one in the trailer. We use a base station to make sure that accuracy is within 2 centimeters at all times, and we run a custom script so we can measure articulation live, and you need to plot that for this test. You need to plot the angle of the trailer relative to the car as the test runs, and how quickly that settles down is the requirement of this test to make sure that when there is a sudden steering input, that the trailer dampens down quick enough and absolutely doesn't go the other direction and get out of control. Combination braking performance or stopping distance is one of the braking tests that we need to do. The braking tests are done with no trailer brakes, so the purpose of it is to verify that the vehicle can stop the combination in the event of an emergency or a failure of the trailer brakes. You don't need to have the frontal area of the trailer up. Arguably, it's better to have it down. It's a bit windy today, so we're not going to be putting that down, but we don't test with it up normally. The track conditions, you need to be no more than 1% of grade in the direction of travel, 2% across the track, and what you need to achieve is a stop from 20 miles an hour or 32.2 kilometers an hour in less than 24.4 meters. So this is just an emergency brake at GCM with just the car slowing everything down. Combination braking stability is one of the brake tests, and its purpose is to verify that in the event of a failure of the trailer brakes, that the vehicle can safely stop from speed. The test is done with the trailer brakes disconnected. Normally we wouldn't test with the frontal area up. We would fold that one down because it makes it a bit harder to pass the test. It's just a bit windy to be doing that and putting it up and down right now. The track conditions, no more than 1% grade forward and 2% across the track. And the test is done from 100 kilometers an hour or 60 miles an hour down to 0, and you need to stay within a 3.5 meter lane using just the vehicle brakes to stop the whole combination. We plot this with our inertial measurement unit and we get a line of where the vehicle and the trailer traveled and draw bounds around them and make sure that they stay within that 3.5 meters. We'll test this on large diameter tyres and also narrow tyres as per the Australian design rules. Park brake performance. This is very similar to the ADR 31 or 35 park brake test, except for the fact that it's done at GCM. So this test is at GCM on a 12% grade, as opposed to the normal vehicle brake test, which is GVM at 18% grade. What that means for common vehicles is an uplift of maybe 30 or 40% in park brake performance required to do it while holding the whole mass just on the vehicle's park brake. So you park on the hill, you do it on the biggest tyres that you have, and it's got a park brake only, no other intervention, hold for 5 minutes, and then you turn around and you do it facing down the hill as well. So there we have it. It's a huge amount of testing, but it does need to be done right to make sure your kits are safe and approved by the state regulators and approved persons. No, not every car can pass it in the OEM or modified condition, but then again, some of them probably shouldn't. So if you've got a need for some GCM upgrade testing for your product development, give us a call at the AIC and we can certainly help you out.